My name is William Rudman, and I'm a postdoctoral researcher at CosmicAI, advised by Jesse Lee. Today, I'm going to present our recent work, VESTA, Visual Exploration with Statistical Tool Agents. The goal of VESTA is to propose statistical models that fit a given input. Fitting models to data is a key part of the scientific discovery pipeline, and the goal of VESTA is to automate this with VLM agents. What distinguishes VESTA from prior work is its ability to retrieve and dynamically create new tools to explore the data and further refine statistical hypotheses. To ensure that tool use and creation are the reasons for the success of our pipeline, we create three variants of VESTA. First, we run VESTA with no tools. Second, we test it in a dynamic setting where VESTA must create tools from scratch to facilitate analysis. And third, we use a library of human-written tools designed to complete specific tasks. The tools that VESTA creates are often very complex and tailored for a specific input. Here, we see an example of an initial proposal from VESTA before any iteration or any tool calling. The VLM critic recognizes that the current proposed model doesn't fully fit the data, and in response, it creates a four-panel tool that each test different hypotheses. The first two tools that we see here are meant to assess the fit of the tails of the data. And these tools show that the current proposed model does not accurately fit these tails. The remaining two panels in this tool investigate the shape of the data, and they show that the current proposed distribution neither fits the peak or the shape of the input data. Now, based off of this response, VESTA is able to propose a new model that accurately fits the input data and recovers the correct ground truth distribution that generates this data. To benchmark VESTA, we built Dawn. Dawn contains two domains, time series and discrete probability distributions, each with three splits, easy, hard, and one split that's designed specifically for astronomy tasks. The two astronomy tasks we consider are modeling gravitational wave signals and modeling initial mass functions. However, Dawn isn't necessarily limited to astronomy tasks and can be applied to any data science domains. So here we look at the performance of VESTA on Dawn, specifically for the probability distribution fitting tasks. And these graphs show the Jensen-Shannon divergence between the true distribution that generates the data and the proposed model that VESTA or other methods create. The first thing that we notice is that VESTA significantly outperforms two baseline methods, with the biggest gains being on the hard and the astro splits. Second, we see that VESTA performance follows a consistent pattern where no tool use is the weakest, expert tool use is the strongest, and the dynamical generated tools land just behind these expert tools. So thank you for listening to my talk today, and please feel free to reach out if you have any questions.